Learn how to optimize Parquet files for improved performance in big data projects, focusing on enhancing data processing pipelines for faster and more efficient analytics. Welcome to our deep dive into optimizing Parquet files for big data projects. Imagine being able to have your data processing times with just a few tweaks. Sounds incredible, right? Parquet files are a cornerstone of efficient data storage and retrieval, especially in data-intensive applications. In this video, we're going to explore practical strategies to unlock faster and more efficient analytics, making your data pipelines not just more effective, but also more economical. Stay tuned as we unpack these techniques in detail. Let's begin by understanding what makes Parquet files unique. At its core, Parquet is a columnar storage file format tailored for efficient data analytics. Unlike row-based formats like CSV, Parquet stores data column-wise, allowing for significant compression and encoding efficiencies. This design is particularly advantageous for querying large datasets, as it reduces the amount of data read from disk. Parquet files also include rich metadata and schema information, which further aids in optimizing data retrieval processes. By leveraging these features, you can minimize input/output operations and speed up your data pipelines considerably. The choice of a columnar storage format like Parquet is not just about efficient storage, it's about unlocking speed and performance in your analytics workflows. Compared to row-based formats, columnar storage allows for higher compression rates since similar data types are stored together. This translates into faster data retrieval, as only the necessary columns are read during analytics operations. The result? Improved performance and reduced costs, making it easier to scale your big data projects. These benefits are crucial for any data-driven organization looking to derive insights quickly without breaking the bank. Choosing the right compression codec is pivotal for optimizing Parquet files. Popular codecs like Snappy, Zip, and LZO each bring distinct advantages. Snappy is renowned for its speed, making it ideal for time-sensitive applications. Zip, while slower, offers higher compression ratios, which can be beneficial for minimizing storage costs. LZO strikes a balance between speed and compression, often used in scenarios requiring fast decompression. When selecting a codec, consider the nature of your data and the specific needs of your application, whether you prioritize storage savings or processing speed. This strategic choice can significantly enhance your data processing efficiency. Row groups in Parquet files are akin to pages in a book. They define how data is chunked and accessed. The size of these row groups is crucial in determining the efficiency of data reads and writes. Larger row groups reduce the number of input/output operations, enhancing read performance, but may increase memory usage. Conversely, smaller row groups improve seek times but can lead to more I/O operations. Striking the right balance is key. Techniques like benchmarking your specific data workload can provide insights into the ideal row group size, ensuring optimal performance tailored to your application's needs. Handling schema evolution in Parquet files can be a daunting task, but it's essential for maintaining data integrity over time. Schema evolution allows for the addition, deletion, or modification of columns in your datasets. Ensuring backward and forward compatibility is key to preventing data corruption or loss. Implementing best practices such as versioning schemas and using tools that support schema evolution can streamline this process. By effectively managing schema changes, you can keep your data pipelines running smoothly, ensuring that your analytics remain accurate and robust as data structures evolve. Apache Arrow is a game changer when it comes to boosting the performance of Parquet file processing. Arrow provides a standardized columnar memory format that facilitates zero-copy reads and writes between different data processing tools. This compatibility means you can leverage Arrow to significantly speed up data processing tasks, reducing latency and improving throughput. Whether you're running complex analytics or handling real-time data streams, integrating Apache Arrow with Parquet can unlock new levels of efficiency. Consider adopting Arrow if your projects demand high performance, especially in environments where speed is paramount. Optimizing Parquet files isn't without its challenges. Common pitfalls include misconfigured compression settings, inappropriate data type selections, and schema mismatches. These issues can lead to inefficiencies and even data corruption. To avoid these, ensure you understand the intricacies of your data and choose settings that align with your project requirements. Regularly validate your Parquet files for consistency and integrity. Troubleshooting tools and techniques, such as diagnostic logging and performance monitoring, are invaluable in identifying and resolving issues promptly. By being proactive, you can avoid costly mistakes and keep your data operations running smoothly. To bring our discussion to life, Let's explore some real-world examples of Parquet file optimization. In one case study, a global retailer reduced their data processing times by 30% simply by adjusting their compression codec and row group sizes. On the other hand, a healthcare provider achieved significant storage savings by adopting a columnar format and integrating Apache Arrow, improving their predictive analytics capabilities. These examples highlight not just the technical aspects, but also the tangible business benefits of optimized Parquet files. Lessons learned from these success stories can serve as a blueprint for your own optimization efforts. As we wrap up, remember that mastering Parquet file optimization is an ongoing journey. We've covered a range of strategies, from choosing the right compression codecs to leveraging Apache Arrow for enhanced performance. Continuous learning and experimentation are key to staying ahead in the fast-paced world of big data. I encourage you to dive deeper into these topics and apply them to your projects. Don't forget to like, share, and comment on this video. Let us know your thoughts and any topics you'd like us to cover next. Your engagement helps us create more valuable content for you.